In this video, we're going to talk about basic trinomial factoring. So when I say basic trinomials, I'm talking about ax squared plus bx plus c, specifically when a is 1. Now, how this is going to work is we're going to start with our trinomial, our basic trinomial here, and it's going to factor into this form where the product, the multiplication of the two numbers, m and n, will multiply to c, and if we add them together, we're going to get b. So for reasons, this is called the product sum method of factoring trinomials. So let's have an example. Let's say we have y squared plus 9y plus 8. So our a is 1, our b is 9, and our c is 8. So we're looking for two numbers that multiply to 8 and add to 9. So factors of 8 that add to positive 9. Well, there's only one pair that will do it, but let's list them all. So 1 times 8 is 8. We add those, that's 1 plus 8, which is indeed 9. So the two numbers that we need are 1 and 8. Notice that if we do 2 times 4, which is also 8, if we add those together, we get 6. All right, so there's only ever going to be one pair of factors that will work in the form. So we set up our answer. We'll have y in front, just like the form does, and then we'll put our factors that we found. So the 1 and the 8. So y plus 1, y plus 8 is our factored form. So let's do this again. We want to factor this trinomial d squared plus 4d minus 45. So we want the factor pairs of negative 45 that add to positive 4. So let's just list them. We'll start at the top of the list. 1 times 45. Well, 1 times 45 is positive 45, not negative 45. So one of these factors has to be negative in order to multiply to a negative. So negative 1 times 45. Okay, that's negative 45. And if we add those, negative 1 plus 45, we get positive 44. So that's not it. What about if we switch it? 1 times negative 45. That still multiplies to negative 45. If we add them, we get negative 44. So anytime we add a factor pair where one of the factors is a negative and one of the factors is a positive, the larger number keeps the sign. All right? So what about the next factor pair? We haven't found our factor pair yet. So 2 doesn't go into 45, but 3 does. So let's see. Negative 3 times 15. Add those, we'll get positive 12. So that's not it. And 3 times negative 15 would give us negative 12. So that doesn't work. 4 doesn't go into 45, but 5 does. What about negative 5 times 9? Add those together, we get positive 4. Okay, there we go. So there's the factor pair that we need. Put it into the form. So our answer is d minus 5, d plus 9. And notice, if we switch them, we put 5 times negative 9 will add to negative 4. So we have to get the same number and the same sign as we do in the middle. Also notice that we can rewrite this as d plus 9, d minus 5, and it is the same thing. Mathematically, they are identical, so the order of the parentheses does not matter, but the signs do. D minus 9, d plus 5 is different. If we check using multiplication, because factoring is undoing the multiplication process, if we check by multiplying, what do we get? We get d squared minus 9d plus 5d minus 45. Combine like terms in the middle, that'll give us minus 4d. So this is not the same thing. Let's have another one. So we have t squared plus 11t plus 12. All right, so we want factors of 12 that add to 11. So let's go down the list. 1 times 12, that 1 plus 12 is 13. 2 times 6, 2 plus 6 is 8. 3 times 4, well, 3 plus 4 is 7. And then we're at 4 times 3, so we're wrapped back around, none of which adds to 11. Is our math wrong? No, our math is fine. Did we forget a factor pair? No, we've listed them all. This is what is known as not factorable, or it's called prime. It is a prime factored trinomial. This cannot be factored. So we're done. There's nothing we can do here. Let's do another one. So we have q squared minus q minus 42. So we're looking for factors of negative 42 that add to negative 1. Remember, when we don't see a coefficient, the coefficient is 1. So negative q becomes negative 1q. So we're trying to add to negative 1. So factors of negative 42. Because it multiplies to negative 42, one of the factors has to be negative, one of the factors has to be positive. So negative 1 times 42, add that, we get 41, way too big. What about negative 2 times 21? Add those, we get 19, still too big. So what about negative 3 times 14? That's getting better, but it's still too big. That's positive 11. And if you don't remember your factor pairs, use your calculator. 42 divided by 3 gives us 14. So we can use our calculators here. So 42 does not divide evenly into 4, doesn't divide evenly into 5. What about 6? There we go. Negative 6 times 7 is negative 42, and that's much better. We add those. Negative 6 plus 7, oh, that's positive 1. So what about 6 times negative 7? Add those. 6 minus 7, that's negative 1. Okay, there we go. So there's our pair. So we put it into our form. So q plus 6, q minus 7. So let's take it one step further. Let's say we had two variables. They gave us two variables here. Well, it's actually not going to be very dissimilar to the examples we've already done, except that in our form, we will have the v will be in front, just like we're used to, and this w here will be in the back because it's in the back. So the v's in front, so it's in front. The w's in the back, so it will be in back. And the rest is the numbers. So two numbers, so factors of 30 that add to negative 11. So how do you have factors that multiply to positive but add to a negative? Well, that would mean they would both have to be negative. Negative times a negative is a positive, and negative plus a negative is a negative. So factors of 30. So negative 1 times negative 30, add those, we get negative 31, way too big. Negative 2 times negative 15, that's better, that's negative 17, but still too big. Negative 3 times negative 10, that's negative 13, getting better. What about 4? Does 4 go into 30 evenly? Let's check our calculator. No, it doesn't. We get 7.5, so that doesn't work. What about 5? What about, it does go evenly, 5 and 6. So negative 5 times negative 6 adds to negative 11, and there's our factor pair that we need. Checks out. So our answer would be v minus 5w, v minus 6w. So not that dissimilar from what we were doing before. So let's have another one. We have 2t cubed plus 8t squared plus 6t. This is a problem. A is not 1. This is our A. A is not 1. So the first thing on our mind is that A is not 1. This could be a problem, but maybe not. If A is not 1, the next thing on our brain should be, is there a GCF that we can pull out? And yes, there is. We have t from every term, and they're all even numbers, so we can also pull out a 2. So if we have a GCF of 2t, so what are our leftovers here? We have, well, remember, when we're pulling out a GCF, we're dividing by that GCF of every term. So if we pull out a 2t, then we are left with t squared plus 4t plus 3. This is wonderful because this is now a form that we recognize. We can do this. So factors of 3 that add to 4. Well, 3 only has 2 possible factors, 1 times 3. And negative 1 times negative 3, but we add to a positive 4, so 1 and 3 is it. So we put this into our form. We'll have t plus 1, t plus 3, and that 2t of the GCF drops down. So our final answer will be all of this, 2t times t plus 1 times t plus 3. All of it is our factored form. Let's do one more. Let's say we'd had something like this. Well, the first thing on our brain is that A is not 1. Uh-oh. Well, possibly an uh-oh. Is there a GCF? Well, yes. Actually, there is. At the very least, we could pull out that forwarding negative. We hate negative there, so we always want to pull that out if we can. All 3 numbers are even, so we can pull out a 2 as well. And we have x to the 6th, x to the 5th, and x to the 4th. So the smallest exponent is 4. So we can pull out a GCF here of negative 2x to the 4th. Remember, when we're doing GCF of variables, it's always the smallest exponent. And the GCF of numbers is the largest number that they all have in common in their multiples. So let's divide to get our leftovers. So what does that give us? That gives us x squared plus negative divided by negative is a positive, plus 4x minus 42 divided by 2 is 21. And anything over itself is 1. So x to the 4th over x to the 4th, that's 1. Okay, so we can do this. We can find the factor of the middle. So we're looking for factors of negative 21 that adds to positive 4. So I'm thinking 3 and 7. But it is a negative 21, so one of these has to be negative. Either it's going to be negative 3 and positive 7, or it will be positive 3 and negative 7. Which one adds to positive 4? Well, 3 minus 7 is negative 4. Negative 3 plus 7 is positive 4. So that's the pair we want. So we put it into our form. We have x in front. We have x minus 3, x plus 7, and the negative 2x to the 4th drops down. And this whole thing is our factored form answer.